Let's see how we can construct the regular representation of S3. So here are the group elements of S3. Let's turn this into an element of the group algebra by taking a linear combination. So we say Q, the group algebra, is of this form. Q1 plus times the identity plus Q2 times this transposition, Q3 times this one, Q4 times this one, Q5 this cyclic permutation, and Q6 this other cyclic permutation. So this is what an element of the group algebra of S3 looks like. And now let's say we want to multiply this Q with some element of maybe this one, some element of S3. So we're going to construct the representation of this pink element here. What will we get? We will get again a linear combination of the group elements. Let's just put this here. But of course the coefficients will be different, because by multiplying with this cyclic permutation we will not get back the same permutations. So how does this go? If we multiply this with the identity, then of course we get back the same thing here. So the Q1, where is it? The Q1 becomes the coefficient of this cyclic permutation here. Now let's multiply with the next one, with this transposition here. We see that, what's that? 2 goes back to 2 and the other 2 swap place. So the Q2 goes here. Now if you multiply with the next transposition, it's this one, then what do we get? Hopla. The last one goes here. So the Q3 coefficient goes where? Goes here. Here's the Q3 in the second place. So what's Q4? Q4 is multiplied with this one, and then we get 1 goes back to 1, so we get this transposition here. So the coefficient Q4 ends up here. Now we multiply this with the same. So we take the square of the pink thing. What's that? 1 goes to 3, 2 goes to 1, 3 goes to 2. So this is the other cyclic permutation. This means the coefficient Q5 will show up here. And finally, we know what has to happen. Let's write down the Q6. It's this one, and that's just the identity. So the Q6 goes here. And now we can read off the representation matrix. Let's call the representation, let's call it R, the regular representation. So this is now a 6 by 6 matrix, and we see in the first position we got the 6th entry, so 1, 2, 3, 4, 5, 6. Then in the second position we got the 3rd entry, 1, 2, 3. In the 3rd we got the 4th, 1, 2, 3, 4. In the 5th we got the 2nd, 1, 2, and some zeros. In the 6th position we got the 1st, 1, a bunch of zeros. And in the last position we got the 5th coefficient, 0, 0, 0, 0, 1, 0. Okay, so this is one representation matrix for an element of S3 in this regular representation.